Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. So let us continue with our subtopic of dynamics, namely kinetics, and so this is how we define the meaning of kinetics. So kinetics is the study of the relation between forces and the acceleration they cause, whereby this relation is based on Newton's second law. If we express in mathematical manner, so the total of force is equal to multiplication between m, the mass, and a, the acceleration. So we can simply say that the second Newton's law is equal to F equal to ma. Alright, so before applying the equation of motion, so it is important to first draw the particle's free body diagram. So this is what it means in order to account for all the forces that act on the particle. So we can easily see from here the particle in blue color, so have been applied with certain amount or certain level of force, and resulting the output force in terms of F1 as well as F2. Alright, so this may cause the acceleration to happen if we cross over to kinetic diagram later on. Okay, but in this particular free body diagram, it is clearly shown over here the multi-level of force. Force number 1, for example, and force number 2 in diversity or different direction. All right, so it may come to one conclusion where the total F is generated. Okay, so we can simply say that Fr equal to the summation of force here, and can be represented the vector into one straight horizontal line. Okay, and then graphically, so this diagram is equal to kinetic diagram. Okay, it shows the result of the forces, that is the ma vector. Okay, so in other words, we can actually represent the free body diagram into a better kinetic diagram with one particle over here, and this is the cause by the force applied, which is ma vector, right? The mass multiplied by the acceleration. Okay, and then we have the displacement, for example, at SO, the initial location, and up to this point, S1, for example, right? This point. So this is the displacement, which is caused by the force applied to the particle, right? And then for a better understanding, we do have example 5. Okay, so the 50 kg crate, so this is the mass of the crate. Okay, so a wooden box, so crate is actually a wooden box over here. Okay, so shown in figure 13.6a, rests on a horizontal surface for which the coefficient of kinetic friction is mu k equal to 0.3. So this is the coefficient of the kinetic friction. Okay, the kinetic friction. So rest means it unmoved or just static over here. So v equal to 0, for example. So no speed or no velocity, as well as no acceleration. So, but there is certain amount of force applied, namely kinetic friction, even though the object is in rest position, which is mu k equal to 0.3. So if the crate is subjected to 400 Newton towing force as shown, so this is the towing force, all right, which is moving to this direction with amount of value of 400 Newton. So determine the velocity, so the v of the crate in 3 seconds starting from the rest. So for example, it moved from here to here from t equal to 0 seconds with 0 speed, and then it moved to this, okay, and then within after 3 seconds, for example, so we have t equal to 3 seconds starting from the last. For we do have from here to here a certain, let's say we have v1, a certain amount of or certain level of speed or velocity. Okay, so we need to determine of this value. Okay, how should we do? So the solution free body diagram. So as shown in figure 13.6b over here. So this is the free body diagram. So the weight of the crate W equal to mg, where we have our mass over here multiplied by g. So this is the value of gravity force. Okay, this is actually the gravity force. So this is the value. Remember, 9.81 meter per second squared. All right. So the force of gravity or the acceleration of gravity. So this is really the acceleration. That's why you can see the unit is over second square. Okay. So the acceleration of the gravity, the force caused by the gravity. So m 50 kg is the mass, multiply both of them. So you may get 490 Newton. Okay. Then shown in figure 13.6b, the frictional force has a magnitude F equal to mu kn and c. So this is over here. So this is the frictional force. Okay. Since the direction is to the right, all right, the direction of the crate is to the right, okay, caused by this value or this force. Now the frictional force magnitude is actually acting oppose the direction of the crate. Okay, so that cause the frictional force. So this means opposite or oppose to the left. Okay, this one. All right, so the magnitude is F equal to mu kn and C. Mu k over here is given in equation 0, again 0.3, substitute into this value. So you may get F equal to 0.3 and C. F equal to 0.3 and C. Right. So and x to the left, since it opposes the motion of the crate. So the acceleration A is assumed to act horizontally in the positive x direction. So there are two unknowns, namely NC and A. So the A is actually the acceleration of the crate, and also the NC, which is the force caused by the fractional act over here. Okay. And then equation of motion using the data shown on the free body. So diagram we have, okay, for F Newton's second law, just to recall, F to ma. So as we derive the equation, so we do have the total of F over here, all right? So in x horizontal direction, okay? So assuming to the right is positive, okay, and then this is equal to m, the mass of the crate or the object, and then a is the acceleration of the object again in horizontal x direction or x position. So the total of f over here is 400, and 400 cos 30 degree is actually over here. All right. So we have the 400 Newton applied force to the crate, and we have 30 degree over here from this arrow or this position to this straight horizontal position. So the gap gives us 30 degree. So the cos of 30 degree multiplied by 400 is actually this straight horizontal line. Okay, this is actually 400. Okay, 400 multiplied by cos 30 cos 30 degree. Okay, so to the right, so this is positive, and then we have the opposite force, which is coming from frictional force. So this is to the left, and this is the negative. All right, so we have over here negative. So you deduct 0.3 NC equal to MA. So M is the create mass, okay, which is 50 kg over here from the question. M 50 kg, and then A is the unknown entity we are going to figure out. And then for the Y position, okay, so we assume that upward is positive. So the total of force act to the Y axis equal to ma. Again, the acceleration to the Y axis. So this is again, sorry, this is yes again for Y and Y. Okay, so NC, so over here, okay, so this is the force at this crate, okay, that's opposed the end over here 490.5. all right, so this is sorry, this is the weight. Okay, this is actually the weight. So we weight, this is equal to mg. Again, just to recap or to recall what we have analyzed earlier, so the weight of the crate, W equal to mg. This is mass 50 kg, and this is the gravity value, which is 9, or gravity acceleration value, this is 9.81. Okay, so must multiply, you will get the weight of the crate. Okay, so going downward, of course, because due to the gravity factor, which attract you to the surface of the ground. Okay, so it will act downward, and then opposed to this force is actually NC. Okay, opposed to this weight is actually NC. So we have NC, which is positive. Okay, so NC, which is negative. This is still unknown. Okay, as mentioned in the question or in the analysis, this is still unknown. And then minus 400 and 490.5 opposed downward negative. Okay, this is negative. And then again, the NC is positive because we have defined in this stage that, okay, positive is upward. And then plus 400 sine 30. So this is actually from here. Okay, again from this free body diagram. So this is the force we apply. Okay, the force we apply, 400 Newton initially, can be derived into this direction force, the Y direction force. All right, so this, or we can actually this force represent in this position. It's the same thing actually. All right, the one I write in blue. Okay, can be here also. Okay, the blue one. So which is acting upward over here. So this blue line is actually, if you refer to trigonometry, so this is actually 400 multiplied by sine 30. Sine 30 degree. Right, it's over here. Okay, and then this is equal to 0. Okay, the MA, the acceleration for this crate actually is moving to the right, is not moving to upward. Okay, so since the acceleration is moving to the right position, so not upward or downward, so we have T kg multiplied by A, which is 0. That gives us 0 value over here. Okay, solving equation 2. So now we have two equations with two unknowns entity parameter, which is A and also NC. All right. So solving equation number 2, substituting the result into equation 1 and solving for A yields this value. All right. A equal to 5.185 meter over second square is this value. All right. So remember, so our crate is moving to the right. Okay, moving to the right with a acceleration. Okay, the acceleration of the crate. Okay, now we just obtain the value of a, which is 5.185 meter per second square. So substitute again this a value into this, for example. All right, and give the value of n and c, which is 290.5 Newton. All right. So kinematics analysis, notice that the acceleration is constant since the applied force P is constant. So the applied force P is constant, which is 400 in the beginning, and then that cause V1 or cause A acceleration, and this is also fixed value. Okay, this is constant. P is constant since the initial velocity is 0. This is what I have explained earlier. So the velocity of the crate in 3 seconds is, so again to the right is positive, right to positive, and then V equal to V. Oh, this is, we can you can see this equation from earlier slide, in the beginning of the slide. So there are certain condition to apply this equation where acceleration must be a constant with P constant, and then only we can use this formula. V equal to V naught, this is the initial V where acceleration is constant. C stands for constant times multiplied by T. So V naught is 0. So the initial V, there is no speed because the crate is resting. Okay, plus 5.15. This is the A. All right, we just calculate A equal to 5.185. So it is constant, and then plus or multiply by 3 seconds. So the equation asks you to find the value of V in T equal to 3 seconds. So solving this gives us 15.6 meter per second. So this is to show or to indicate the direction of the current, which is to left. If negative value, so you just change instead of to the left, so you have to the, sorry, instead of to the right, you have to instead to the left. All right, to the right is positive. Again, to recall in this particular example, if the value is negative, just in case, that means you need to change the position of or the direction of the arrow. So this is negative. All right, so just for example. So this is what we have analyzed. So we do have the weight of the, again, the weight of the crate, which is 490.5. This was the weight. So opposing the weight is actually NC. Okay. So opposing the weight is NC. The force to withstand the coming force caused by weight. Okay. To make the to cause the crate to rest, okay, or stand still. Okay, so coming from gravity, the weight and of the mass, and then opposite to it is NC. Similarly, if we apply 400 meter to move the crate to the right or this position, so we have the, again, the opposite force to it is actually frictional force 0.9, 0.3 NC. So this is a free body diagram analysis, and then we try to convert to kinematics approach. Okay, so kinematic approach comes in M and A, mass and acceleration. Okay, so 50 kg multiplied by A. Okay, so to this of direction of course. And then example number 6, a 10 kg projectile is fired vertically upward from the ground with an initial velocity of v naught. Okay, this is v. If we can write over here, this is the initial v of v naught. This is equal to 50 meter per second. So figure 13.7a. So this is the illustration, the photo we can imagine. The projectile is coming upward over here from the surface of the ground. Okay, with the initial speed of the projectile, the object is 50 meter per second. So determine the maximum height. So this is the maximum height, for example. All right, so h max, okay, of the object or of the projectile can reach, or it shown over here, z. Okay, shown over z. Maximum height to which it will travel is a. Atmospheric resistance is neglected. So the atmospheric resistance, the force which is opposed the act or the motion of the projectile. So we have over here Fd, for example. Okay, so this is the atmospheric resistance which acts opposed to the projectile motion. Okay. And then this is the first condition. And then the second situation, atmospheric resistance is measured as Fd equal to 0.01 V square. Right. So this is in the time, sorry, it is depend on the value of V square, the speed. All right. So where V is the speed of the projectile at any instant. All right. So and then project. Okay, never mind. You go to the solution first. Part A, free body diagram. So this is shown in figure 13.7b. Right. So you can see the projectiles. This one. All right. And the weight is acting or moving downward. The weight of the projectile or the object. So we have W equal to M, G over here. So we have the mass in kg, 10, and then the gravity acceleration is 9.81, thus resulting 98.1 Newton. So this is the value of the weight of the projectile. Okay, again is moving downward, acting downward. So we will assume the unknown acceleration A acts upward in the positive direction. All right, so this is the motion or the acceleration caused by projectile. See here, so over here. Okay, so in moving upward z direction. Okay, so which is causing, or this is which is producing the speed of or the acceleration of A. Okay, and then equation of motion moving upward is positive. Okay, the sum of F in z direction equal to ma. So this is F, the total here. All right, the weight of the projectile itself is being used to calculate the F equal to ma. All right, remember the weight is acting downward. Okay, but in the beginning, so we have defined that positive is upward. Okay, that's why we have negative sign over here. Okay, negative 98.1 equal to m. This is m, the projectile's weight, which is 10 kg multiplied by A. Okay, so A After you solve this equation, so they will give you that A equal to negative 9.8181 meter per second square. So this result, so what the result indicates? So it shows that the projectile, like every object having free flight motion. So it's a free flight motion actually. This one, if free flight motion, okay, motion near the Earth's surface is subjected to a constant downward acceleration of 9.81 meter per second square. So subjected to constant downward, which is the gravity force over here. Okay, downward. So it's actually same acceleration. Okay, the same acceleration of the object, which is A. Okay, but in different, of course, in different direction. So one positive and one negative. This is negative, this is positive. So initially, so Z naught equal to 0, V naught equal to 50 meter per second. Okay. So Z naught is actually the what? So this is the position. Okay, the location. So here, for example, so this is a Z naught, right? And V naught, so the initial speed is given in the question, which is, where is it? 50? Oh, not this one. This one. Okay, sorry, this one. Okay, this is V naught, as I mentioned earlier. So V naught 50 meter per seconds. Okay. And at the maximum height, Z equal to H. Okay. So we have Z naught as the initial position. Okay, over here Z naught. Now we have H, which is the maximum Z of the projectile may go. Okay, before it fall down again. Okay, so since the acceleration is constant, so then, okay, again we use this equation. You may find this equation in the beginning of this lecture or this topic. So v square equal to v naught square plus 2ac. So this is the displacement, okay, between the maximum z and the initial z, which is z naught. So this is the initial. Okay, this is the initial, and then this is the maximum z or position or distance we are going to calculate. Okay, so substitute the value of v naught, which is 50 meter per seconds, plus 2. So this is the AC. We just figure out this is here, okay, with negative signs. And then we have H, where we have defined the maximum Z over here. H maximum, this is the maximum Z over here. And 0, of course, the initial position, okay, at 0. Z not at 0. So again, this is Z, which is the maximum height of the projectile. Okay. So rearrange the equation and try to solve value of H. Okay, that result in 127 meter of the projectile or the object may fly or may go. Okay, and then part B, the free body diagram. So since the force Fd equal to 0.01 z square, so this is given here. All right. So now we have to consider the atmospheric resistance. Okay, we try to calculate the height of the projectile. Okay, again we need to find the height of the projectile over here, H max or Z. Now with considering the atmospheric resistance, okay, which is measured at Fd equal to 0.01 v square, where v is the speed of the projectile. Okay, and then this is taken into account, where tends to retard the upward motion of the projectile. It acts downward as shown in the free body diagram, figure 13.7c. So we have here, all right, So this is what the weight of the projectile. So now we have the atmospheric resistance, which is acting downward, okay, or moving downward, which is opposed the movement or motion of the projectile. Remember, projectile is moving upward, okay, with a acceleration. Okay, so this is the motion of the projectile. It is moving upward to the z direction or to the z position with a acceleration. But when it comes to the force, so there are certain force act to this motion. Okay, namely again Fd as well as the weight of the projectile itself. So equation of motion. So again, so we define upward is positive. Okay, total of Fz in here, the Fz over here in Z position, for example. All right. So again, upward. This is equal to M and A. This is A with Z direction again. Okay. And then this is actually the Fd value. Okay, this is Fd. All right, the atmospheric resistance is taken from here. Okay, with negative sign because of the direction again here. This is downward. Okay, so that's why we put negative signs. So similarly, for the force of the weight of or the weight itself of the projectile downward. Okay, again, we have negative 98.1. Okay, so this is equal to MA, where M is 10 kilogram. So rearrange and solve the question. So A is equal to minus 0.01 V squared plus 9.81. So kinematics here, the acceleration is not constant since Fd depends on the velocity. So since A equal to Fv, so once the acceleration or the value of V, for example, is not constant, so the value is changed according to the speed, according to the times, whatever it is. So for example, in this acceleration, of course, it is depends on the velocity V. So A in the function of V. All right. So if V is the function of time, for example, so if we have A acceleration, which is the function of V. Okay. So we can relate A to position using, okay, again upward positive, A dz equal to V dv. Okay. So according to this relationship, so we are able to do the derivation or to solve this situation. So we have again A is taken from here, this A, all right, negative blah 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 blah. So into this A, all right, into this A. Okay, change the color again. So into this A, all right, and dz remain dz over here. So this is A, and dv and dv remain. All right. All right, and then what we do next is we try to solve this relationship by integrate both sides. Okay, integrate both sides. Okay, separating the variables and integrating, realizing that initially z not equal to 0. Yes, the initial position of the projectile is 0. So the initial speed is actually given by the question 50 meter per second, which is positive upward, and z equal to h. So the maximum z equal to h, maximum height, and v equal to 0 because at the maximum height, so we have our projectile, for example, here. Okay, so this what do you call it, this projectile is moving upward, for example, up to this level, and this is the maximum h. the steel or the iron ball may go before it start to fall again. So this is surely v equal to 0. So no speed at all. That's why the projectile start to fall down. Okay, it stopped the velocity at h equal to maximum. Okay, z maximum. So at maximum height v, the speed is 0. So we have over here, so integrate dz from 0 to h. Okay, so the z is the position. So we try to derive from 0 to h, right? The maximum height the ball or the projectile may go. And this is from 50 initial 50, the speed up to 0. Okay, so the height is up to h. So dv over 0.01 v square plus 9.81. This is actually from this value. Okay, this value. So rearrange, go downward here. Okay, so we have v dv over all this. Okay, so rearrange. So this means we put v into one side. All the v over here, v squared, we have v, and we have dv put into your right hand side over here. So we have all the d, the v, the dv, and as well the v squared over here. Okay, v and dv. And then if you integrate this, you may go to integration subtopic. So you may find this answer. Okay, minus 500, and of course you need to substitute value of 0 and value of 50. Okay, so substitute into this v and this v after you have done the integration. Okay, so this is after you have done the integration, and then you got minus 500 ln v squared plus 9,810, and then again substitute. This is what I mean just now. So substitute the value of v equal to 0 and v minus v equal to 50 meter per seconds. And then finally you will get z. Okay, this is z equal, so this is z maximum actually. Okay, z maximum, which is h. Okay, because you need to substitute the value of h. Okay, h into here. So h is 114 meter. So we have done the previous analysis where we do not consider the atmospheric resistance is neglected over here. Question number A. So when we neglect the atmospheric resistance here, FD, okay, so we got 1 to 7 meter. Okay, and then after we consider the atmospheric resistance, so certain amount of additional force which is act to the projectile. Okay, this iron ball or steel ball. So this gives us lower value of h, which is 114. So what this means, so indicates a lower elevation that obtained in part A due to atmospheric resistance or drag. Okay. So due to the atmospheric resistance, so the ball rise or elevate lower than the previous analysis, which is 187 meter. So now example number 7. So the baggage truck A shown in the photo has a weight of 900 pounds. So this is the imperial unit. So non-SI unit, and tows. So it tows or it drag 550 pound cut B and 325 pound cut C. So we have our truck over here. We have cut number 2 and cut number 3, which is cut B and cut C. So for a short time, the driving frictional force developed at the wheel of the truck A if 400 T pound. So T here is actually time. Okay. So the force or the fractional force developed by this one FA. Okay, this FA developed by this truck wheel or tire is 40 T. Right. So again, T stands for times. So where T is in seconds, if the truck starts from rest, determine its speed in 2 seconds. Okay, from rest. So if we have to determine the speed of the trucks after 2 seconds. So we have here T equal to 0 at standstill condition, for example, at resting position, and then we need to find the speed. So we need to find the speed. So also, what is the horizontal force acting on the coupling between the truck and cut P at the instant? So after 2 seconds, we need to analyze the coupling. All right, over here between truck and cut B here. So the force, right? So we need to find the horizontal force. So if to the right or to the left, horizontal. Okay, force that act to the coupling between truck A and also cut B. Okay, so neglect the size of truck and cuts. So solution as shown in figure 13.8a, it is the frictional driving force that gives both the truck and cars an acceleration. So here we have consider all three vehicles as a single system. So according to this figure, so we have seen the frictional here. So we have the NA, the force for the truck A, so NB for cut B, and so NC for the cut C. By the way, for the frictional force, it is actually applied on truck A. So here, okay, and then the only motion in the horizontal direction has to be considered. Of course, there is no any vertical direction. So there is no any upward or downward direction. This is only for equation of motion. Okay, so we have again to the left, since our truck is moving to the left, so we have positive for that, and then total of fx in x horizontal, x axis. Okay, so we have m equal to a, so f is 40 t, so this is the fractional force given in the equation here, fe. All right, so fe is 40t, or here 40t, so it's moving to the left, similar direction as the truck. Okay, as the truck. So we have positive over here for t. So this is equal to total value of m. So this is the total value of m, which is m for truck A plus m for truck B plus m for truck C. If you go back to this question, so you may find the value of pound, as I mentioned earlier, pound, and at the pound, this is the non-SI metric, or particularly the imperial unit. So accordingly, we may change the value of pound over here when we come to this formula, F equal to MA. All right, remember F2 equal to MA. If we analyze in non-SI, or we analyze in imperial unit, so M must be in slab unit. All the previous analysis, we have seen that M, if in SI unit, so you may use kg. All right, this is for SI. Right, kg, meter and all that, this kind of thing. But when we come to imperial, okay, this is imperial or non-SI unit, so you have to use slug for the M instead of pound. So this is pound LBS. Okay, this is another pound which is LBS. Okay, this is another pound which is LBS, and all this need to be converted into slug. How? Okay, so this is the relationship. Okay, one slug equal to 32.2 pound. Okay, so since 900 plus 550, 325 pounds to be converted into slug, so you have to divide it by 32.2. Okay, so now everything in this bracket is already in slug unit. Okay, divided by 32.2. Okay, so multiply by A. So the speed which we are going to obtain. And then rearrange the equation again, solve for A. So you may get A in the function of t time, which is 0.725 t. Okay, and then kinematics analysis, since the acceleration is a function of time, so this one, acceleration in the function of time, all right, so we have 0.7256 t, so it's a time dependent. And then the velocity of the truck is obtained using A equal to dv over dt. All right, so you see that A equal to dv over dt, because at the end of the analysis we are going to find the speed, which is velocity, the v. Okay, so you have to find the perimeter involving or relating to A, t as well as v. Okay, so with the initial condition that v naught, because it is from resting position, standstill position, so no speed at in the beginning, and of course t also 0. Okay, it has not started yet, so t is not started moving yet. So we have dv 0 from rest to v. The value of v we are going to obtain, so question mark, which the value of v here. All right, so from this actually, okay, from this, so from this we have A over here equal to dv over dt, all right, and then so from here we rearrange, we have A, so from here to here, so we have A equal to, sorry, so we have A dt, so this is equal to dv. Okay, so A dt equal to dv, so we rearrange, we got dv equal to A dt. Okay, so of course this parameter need to be integrated in order to find the value of v, or to solve this equation. Okay, so dv is over here, and this whole element is over here. Okay, so what is A? A is taken from here. A equal to 0.72560. So A equal to 0.725 60. Sorry, and dt. So from time, the beginning is time is 0 up to 2 seconds. So why 2 seconds? So because this is the requirement from the question. So they ask you to find the value of v up in 2 seconds. All right, 2 seconds. Or here 2 seconds. And then solve this integration. So you may get that value of v is equal to 0.362 t 6 to 8 t squared. So this is the v from 0 velocity t, sorry, from t equal to 0 up to 2 seconds. All right. So t is over here. So substitute the value of 2 seconds 2 as well as 0. So you will get the value of v in feet per seconds. Okay, so this is imperial because again everything in pound, pound, pound. Okay, so you have changed to slug to maintain the value of or to maintain the unit of imperial. Okay, it's over here. Imperial. So you may get the fun instead of meter. Now we have feet over seconds. The speed of the v. Okay, answer 1.545. So since the acceleration is a function of time, the velocity of a truck is obtained using a dv over dt. Okay, so with the initial condition that v naught equal to 0 at t equal to 0, so we have, okay, again, so this is from this relationship. Okay, you just rearrange integral from 0 to v for the dv as well as for the dt 0.00 to 2 seconds. Okay, so this is the v, oh sorry, this is from what we have done earlier. Sorry for the mistake. So this is actually from here. This is same thing, kinematics, kinematics, kinematics. So this is the same thing, kinematics, kinematic, kinematic. So sorry for the double analysis. So free body diagram in order to determine the force between the truck and cart B. So this is how we analyze the coupling force over here. Okay. So we have cart number B here. Okay. So we need to analyze the force X to the coupling. Okay. We will consider the free body diagram of the truck. So we can expose the coupling force T. Okay, the name of the coupling force is actually T over here. So as external to the body free body diagram, figure 13.8b. So we have again the FA, the fractional force over here. So we have NA, all right, over here, and then we have the mass of the truck itself over here. So we do have the additional force we're going to analyze, which is T, okay, in between truck A and cart B. Okay. So when T equal to seconds, so then the total total F force X equal to MAX. So again, to the left is positive. Okay, we have 40T. This is actually 40T from question. The value of FA. Okay, the one I highlight in blue here, I circle in blue, FA equal to 50, just to recall where the value comes from. So 40T, this is actually FA. Okay, remember the total of force X in horizontal direction. Okay, horizontal direction, we do have FA as well as ST. Okay, to the left is positive. Okay, so T is to the right, which is negative. Okay, so the T is actually again, so the coupling force where the truck A need to pull. This means there is opposite force T X to the truck A. That's why we have this direction. All right, from here to here. So the negative direction. All right. So we have negative over here due to this one. Okay, the one I highlight here. All right. And then we have again M and A. So M 900 kg for the mass of the truck A. Again over 32.2 because we need to convert everything into slug. Okay, into slug. And then we have A over here. Remember this is A equal to 0.7 here. This is A. Okay, this is A. So let me rewrite for you. So we have A equal to 0.7256 T actually. Okay, T is 2 seconds into this T. Right? And then again, T also into this T. Okay. Then from here, the unknown value, the unknown quantity is only T. So for that, we can solve the solution where the T is in pound, okay, imperial unit, value is 39.4. Try and obtain the same result by considering a free body diagram of cut B and cut C as a single system. Okay. Thank you very much for your time and see you in the upcoming topic. And I hope you enjoy the video. Thank you very much again.